Hello everyone, today I will explain 5 technical questions from the CCNA. Let's look at the first question. The first question is about the issue of PoE power supply. It states that when we enable the PoE power feature, specifically the power coverage feature, what will the switch ports do? What kind of operations will the switch ports perform? First, let's look at option A. Option A states that the power usage of the switch port and the data flow of the connected device will temporarily pause. This description is not very accurate. Additionally, option C is also not very accurate in its description. What does this mean? It says that if the switch determines that the device is using low power, which is the minimum configuration power, then the device will malfunction and the connection will be disconnected. The descriptions in both option A and option C are not very accurate, and option B is completely wrong. This option states that when the powered device is enabled to receive power from the PoE switch, what will be generated? A log information. This log information can be available, but it is not a core function of the PoE feature, specifically the power classification coverage function of PoE. So this option is completely wrong. So the correct option should be D. Option D states that if the monitored power, that is the port's power, exceeds the maximum management value, then the port will be shut down and enter an error-disabled state. This is correct. Let's look at the correct answer. Correct answer is option D. All right, then the next question. The next question is about this kind of span and leaf structure, which is essentially the network of a data center. The data center will have this kind of span and leaf structure, and it asks what the function of this structure is. Then let's look at option A, which says that this structure provides predictable latency for traffic between endpoints and endpoint devices. This predictable latency for traffic is basically correct, so we'll keep it in consideration for now. Next, let's look at option B. Option B says that not only is it directly connected to this span, the multicast traffic sent between these servers, this has nothing to do with multicast traffic. Multicast traffic, so the mistake with multicast traffic is here. Then the third option, option C, it says by adding this leaf, and then adding this type of switch, which is an access switch. And generally, it's like this. The span is here. And below is the leaf. And in the data center, it establishes this channel between the leaves, this channel, which initially controls the layer, and then it will transmit the routing through this span device, these two span devices. However, the tunnel is established between the leaves. It says adding a leaf, adding this type of switch is to alleviate network congestion in this way, but this doesn't really relate, so this is incorrect. Then the fourth option says to limit, that is, the leaf device, its payload capitalization. Oh, this answer is also quite nonsensical. So the correct answer is still option A, Choose A. Okay, let's look at the third question. The third question, it asks about the data plane on the network. The data plane, what operations does it perform? Well, the data plane performs forwarding operations. There's nothing much to say about it. It forwards data to the next hop, right? As for option A, which talks about constructing a routing table, that's indeed incorrect. Then finding the outgoing interface in the forwarding database. This is called recursion to the outgoing interface, which is also wrong. Then providing this command line type of this kind of control, access control, that's also wrong. So the correct answer is very straightforward. It's B. Let's look at the correct one. Choose B. Okay, the fourth question is about the control plane. Generally, when questions are set, they like to do it this way. That is, first, if you see the data plane, there will be things like the control plane and management plane. And then it asks, what does the control plane do? The control plane, let's say, for example, your customer's CE, right? It connects to the enterprise's PE. And then this enterprise connects to the operator's PE, the operator's PE equipment. This PE equipment is connected to many P devices in the middle. The P devices are used for forwarding, whether it's forwarding data or routes, and then it transmits to another place, right? It transmits to another boundary and then passes it to the enterprise's private network. So for the operator in the middle, for the operator's network, we need to deploy at the base layer. This is the intermediate system to intermediate system protocol, and at the upper layer, deploy the BGP protocol. What are these protocols used for? They are actually used for routing, for creating routing tables, right? It means allowing these devices to communicate, and once they are connected, my PE and PE can establish a logical tunnel through the BGP protocol, right? It's a direct logical communication, a neighbor relationship. So to put it simply, what does the control layer do? The control layer is for creating routing tables, right? Creating routing tables it's about choosing A, right? This is also very straightforward, just choose A. So let's look at the correct answer. Choose A. Okay, question 4. Question 5. Question 5 is a multiple choice question. This question may be a bit difficult. Let's analyze it. It says, the fifth question states that when we need to use this 2.5 Gbps, this is the forwarding rate, and then 5 Gbps, where BPS is its unit. How much is transmitted per second, this unit? Then when using these two rates, which of the following cables must be used, which type of cable that supports these two, 2.5 Gbps and 5 Gbps? First, let's look at option A. What is option A? This is a fiber optic standard, and the fiber optic standard usually, just the regular fiber optic standard, usually supports this 1 Gbps rate. So what is the second one? This is this A option. This is what I meant to say. Option A. Let me clarify. This 10 Gbps connection supports a speed of up to 2.5 and even extends further up to an impressive rate of 5 Gbps. And then there's also something else about it being just your standard and typical ordinary setup. What exactly was it again? It's a fiber optic standard, which is a standard. It's a standard commonly used in networking, and this standard only supports 1 Gbps. Now the following option C, this is an enhanced category 5 copper cable, which generally supports 1 Gbps, but under short distances or optimized conditions, it can support 2.5 G and 5 Gbps. Then below is the standard copper cable, which is category 5 cable, category 5 copper cable, Ethernet, twisted pair, it only supports 100 Mbps. 100 Mbps. Correctly speaking, below this level of Mbps speed, the C category known as Cat3 is even more outrageous. What does it support? This is a very old telephone line standard from years ago. You know it supports only 10 Mbps. So looking at it this way, if we choose 2, then A is definitely correct. Then there is another one, which is C. Let's look at the correct answer. A and C. Okay, submit. All correct. If anyone wants to learn Cisco technology or obtain Cisco question banks, please contact me, or you can leave a comment below the video for technical exchanges.